Hello, in this lecture I will prove the Pythagorean theorem. The Pythagorean theorem relates to a right triangle, that is to say a triangle in which one of its angles is 90 degrees, like the right triangle in the right side of the picture, and it actually says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or in mathematical notation, c square is equal to a square plus b square. Again, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. C square equals to a square plus b square. Okay, in order to prove the theorem, I built a copy of this right triangle in the left side of the picture, and I built it in such a way that actually inside B of the right triangle I built side A in the same straight line, and then I raised a perpendicular in size of side B to side A. So actually the angle between side A and side B in the left triangle is 90 degrees, exactly as the same. It is the same angle as the angle in the right triangle. It is also 90 degrees. The angle between side A and side B in the right triangle. So actually we have here two triangles that have two sides that are equal to each other. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle is equal to side B in the left triangle. And also the angle in the between side A and side B in the right triangle is equal to the angle between side A and side B in the left triangle. So, because of the fact that we have two triangles that have two sides that equal to each other, and also the angle between those two sides are equal to each other in those two triangles, we can say that the right triangle coincides to the left triangle, or the triangles are coincides to each other. And for that reason, the third side of the left triangle must be side C, because it is side C in the right triangle, and the triangles are coincides to each other, so they have the same sides. Okay, so if the third side in the right triangle is C, so it must be C in the left triangle. Okay, so suppose that we call to the angle between side A and side C in the right triangle alpha. Okay, then the angle between side A and side C in the left triangle must be also alpha, according to the rule corresponding angles in coincides triangles are equal to each other. Okay, and according to the rule that corresponding sides in coincides triangles are equal to each other, so if this side is C, so in the right triangle, so in the left triangle, the third side must be C. Okay, because those two triangles coincide to each other. So they have coincides sides, and also they have coincides angles. Okay, so suppose that we will call to the angle between side B and side C in the right triangle X. We call it X because we don't know the size of this angle. So, but we do know that in every triangle in the world, the sum of its angle is always 180 degrees. So the sum of the angles in the right triangle, in the right side of the picture here, must be 180 degrees. We can write that alpha plus x plus 90 degrees are equal to 180 degrees. Okay, it is correct for every triangle in the world. The sum of its angles, the sum of its three angles must be 180 degrees. So alpha plus x plus 90 degrees are equal to 180 degrees. Now we can subtract 90 degrees from both sides of the equation, and we will get that alpha plus x is equal to 90 degrees. As you can see here, alpha plus x is equal to 90 degrees. Now we will subtract alpha from both sides of the equation, and we will get that x is equal to 90 degrees minus alpha. Okay, x is equal to 90 degrees minus alpha. Okay, x equal to 90 degrees minus alpha. So we know that this angle is 90 degrees minus alpha. Now we also don't know what is the size of this angle in the middle triangle between side C in the right triangle and side C in the left triangle. We have angle that we don't know the size of that angle, so we will call it Y. But we do know that in every straight line has two sides, the upper side and the bottom side. In every side, the sum of the angles is 180 degrees. So x plus y plus alpha is equal to 180 degrees. Okay, x plus y plus alpha is equal to 180 degrees. And the same thing is correct for the bottom side. The sum of the angles in the bottom side is also equal to 180 degrees. In this case, we have only one angle in the bottom side that is equal to 180 degrees. So in total, the sum of the angles in the upper side plus the angles in the bottom side is always equals to 360 degrees. But if we relate only to the upper side, we can say that the sum of the angles in the upper side of the straight line is 180 degrees. So x plus y plus alpha is equal to 180 degrees. But we know that x is equal to 90 degrees minus alpha, so we can substitute x by 90 degrees minus alpha. And then we will get that, so we substituted x by 90 degrees minus alpha, and we get that 90 degrees minus alpha plus y plus alpha equals to 180 degrees, but minus alpha plus alpha is equal to 0, so we can eliminate alpha from the equation. So 90 degrees plus y is equal to 180 degrees, so we can subtract 90 degrees from both sides of the equation, and we will get that y is equal to 90 degrees. Okay, y is equal to 90 degrees. So we know that this angle is a right angle. So the middle triangle is a right triangle, and this angle is a right angle. Okay, so we can write here that y equals to 90 degrees. So we also know that this is a trapeze. A trapeze is a square with a pair of parallel sides. Side A is parallel to side B, and for that reason it is a trapeze. Now we will calculate the area of this trapeze in two ways, and actually we will get the same results, and then we will compare the results in the first way of calculation to the result of the second way of calculation, and from that equation we will derive the Pythagorean theorem. Okay, so we will calculate the area of this trapeze in the first way. We can say we can call the area of the trapeze S. So S is equals to the sum of the parallel sides, that is A plus B, times the height of the trapeze, that is also A plus B, and we divide all by 2. So the area of the trapeze in the first way of calculation is the sum of the trapeze, the sides of the sum of the parallel sides of the trapeze, that is A plus B, times the height of the trapeze, that is also A plus B, divided by 2. So that is the area of the trapeze in the first way of calculation. Now we will calculate the area of this trapeze in a second way. We can say that the area of the trapeze is actually the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. The sum of the areas of these three triangles equals to the area of the trapeze, because of the fact that the trapeze contains three triangles, and the sum of the areas of these three triangles is equal to the area of the trapeze. So we can say that S is equal, is the area of the trapeze is equal to the area of the right triangle, and the area of the triangle is its base times its height divided by 2, so its base is B, times the height to the base, that is A, divided by 2. So B times A divided by 2 is the area of the right triangle. It is in the right side of the picture, and it is also right triangle because it has an angle that is 90 degrees. And so, and its area is b times a divided by 2. So now the area of the middle triangle is equal to its base times its height, the height to the base divided by 2. So the base of the middle triangle is c, and the height to the base is also c. We divide it by 2. So the area of the middle triangle, that is also a right triangle because it has an angle of 90 degrees, is c times c divided by 2. Or c squared divided by 2. And the area of the left triangle is the base of the triangle, that is a, times the height to the base, that is b, divided by 2. So it is a times b divided by 2. Okay, so actually, and the sum of the areas of these three triangles equals to the area of the trapeze. So we arrived to the area of the trapeze by calculating the sum of the areas of the three triangles that the trapeze contains. It contains the right triangle that its area is b times a divided by 2, plus the area of the middle triangle that is c squared divided by 2, plus the area of the left triangle that is a times b divided by 2. So the sum of the areas of the three triangles that the trapeze contains equals to the area of the trapeze. Okay, so we calculated the area of the trapeze in two ways, and of course the expression 1 is equal to expression 2 because we calculated the area of this trapeze in two different ways. So of course it is the same area. So we can actually say that expression 1 is equal to expression 2. And in this way we will create another equation that says that expression 1, that is the area of the trapeze, is equal to expression 2, that is the area of the same trapeze that was calculated in a different way. Okay, so we will write the new equation that says that expression 1 is equal to expression 2. So expression 1 is a plus b times a plus b divided by 2. That is the first expression of the area of the trapeze, and it is equal to the second expression that is also the area of the same trapeze that is calculated by a different way. So the area of the trapeze in the second calculation equals to the area of the right triangle plus the area of the middle triangle plus the area of the left triangle. Okay, so here the area of the trapeze in the first way of calculation equals to the area of the trapeze in the second way of calculation, and it is actually the area in the first calculation equals to the sum of its parallel sides, that is a plus b, times the height of the trapeze, that is also a plus b, all divided by 2. So that is the area in the first calculation, and the area in the second calculation is actually the sum of the areas of the three triangles that the trapeze contains. So it is the sum of the area of the right triangle, that is b times a divided by 2, plus the area of the middle triangle, that is c squared divided by 2, plus the area of the left triangle, that is a times b divided by 2. Okay? So we will multiply the equation by the two sides of the equation by 2. We will get that a plus b times a plus b equals to b times a plus c times c, that is c squared, plus a times b. So here we multiplied the two sides of the equation by 2. Now BA plus AB is 2AB, and C times C is C squared, so we will write it down. So, as I've already said, BA plus AB is 2AB, and C times C is C squared. In the left side of the equation we have brackets, so we will open the brackets. After we open the brackets, we got that a times a is a square, and a times b is ab, and b times a is ba, and b times b is b square. And all this, the left side and the right side is not changed. It is 2ab plus c square. And we know that AB plus BA is 2AB, so we will write it down. So, in the left side we have a square plus 2ab plus b square equals to 2ab plus c square. So we can subtract 2ab from both sides of the equation. So after we subtracted 2ab from both sides of the equation, we got that a squared plus b squared equals to c squared, and this is exactly the Pythagorean theorem that says that the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or c squared is equal to a squared plus b squared. So we can summarize and say that in the first we add the right triangle, and actually the Pythagorean theorem says that in a right triangle the square of the hypotenuse is equal to the sum of the squares of the perpendiculars, or c square is equal to a square plus b square. Again, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. C square, that is the square of the hypotenuse, is equal to the sum of the squares of the perpendiculars, that is a square plus b square. And actually we made a copy of this right triangle here in the left side of the picture, and then we actually calculated the angles in these two right triangles, and we arrived to the conclusion that the middle triangle is also a right triangle, because angle y is equal to 90 degrees. So we have here 3 right triangles. Then we calculated the area of this trapeze in 2 ways. A trapeze is a square with a pair sides that are parallel to each other. A square which has a pair sides that are parallel to each other. A is parallel to B. For that reason, this is a trapeze, and we calculated the area of the trapeze in 2 ways, and then we actually compared expression 1 to expression 2. We said that the area of the trapeze in the first calculation is equal to the area of the trapeze in the second calculation. In the first calculation, we said that the area of the trapeze is equal to the sum of its parallel sides times the height of the trapeze divided by 2. And in the second way of calculation, we said that the area of this trapeze is the sum of the areas of the 3 triangles that the trapeze contains. So it is the sum of the areas of the right triangles plus the area of the middle triangle plus the area of the left triangle that the trapeze contains. Then actually, as I already said, we said that the area of the trapeze in the first calculation equals to the area of the trapeze in the second calculation. After we developed this equation, we get the final results that says that the square of the hypotenuse in a right triangle is equal to the sum of the of the squares of the perpendiculars. The square of the hypotenuse is equal to the sum of squares of the perpendiculars. Okay, c square is equals to a square plus b square. Okay, Thank you very much.